I think I am live now. Can anyone confirm if audio and everything is fine? Like, I am planning to discuss all the problem except the last send cut problem today. I think I am live now. Can anyone confirm if audio and everything is fine before we get started for today? Hello. Okay, thanks everyone. I think we can start now. Yes, after a long time. But I am hopeful that I would be regular for at least 2 3 weeks. Just give me a minute and oh, 1 second. Let me see like why my screen is not working and probably something else is required. Just 1 second, like not sure why like the whiteboard has a lag. Looks like whiteboard missing. Just give me 2 minutes. Okay. Just give me like whiteboard is not at all working today. So I will probably try to do it using Zoom and call it out. Sorry, like there are some network lags. I am trying to fix the stuff before getting started. Just give me a minute. Like basically, I am trying to get things ready. Yeah, just give me 2 minutes. Like I'm starting from a long time, and like there is the non-trivial lag of the problem. 816. No, this fine. Whiteboard. Okay, looks fine. Okay, looks fine. I think we can start off. Sorry everyone for keeping you waiting, and I think it's better. Mhm. Mhm. Not really sure like why there is a non-trivial lag for me today. Okay, I will start now. Just hoping that everything will work fine. So like let's start from the easiest problem. Lucky cover. Chef heard that the two leaf clovers bring good luck, so he went looking for it. In his search, Chef has found n clovers in total. Out of them, exactly one has four-leaf clover, and all of the other have three-leaf clovers. How many leaves Chef did collect in total across all the clovers? So here it says like Chef has n minus ones with three leaves and one with four leaves. So we can print 3 into n minus 1 plus 4, which is equal to 3n plus 1. And essentially this would be the answer here. Take n as input 3 into 3n plus 1, and this should be enough for the first problem. Nearly equal hammering distance between two pair of strings of equal length is defined to be number of positions at which they contain different characters. For example, hammering distance between there and Shreya is 2, as their first and third characters are the only different color. H, R, E are same at both the positions. While the hammering distance between order and chaos is 5 because all the color at each of the positions are different. It says given a string A of length and Chaos favorite string is B of length n, and it's known as M is less than equal to M. Find the minimum hammering distance between B and some continuous substring of A that has length n. The important thing here was like the constraints are everything less than equal to 100. So what we can do is like we know like this would be the string A of length n, right? And we have some string B of length n. What we can do is like for example here we can try out all the possible strings here, like this is length 5, right? So all the possible strings of length 5, these would be the strings. So we can try out all such strings. We can use substr method in C++. In Python you can directly use slice to first get all the strings of length m. So for example, I have taken A and B as input. For all the starting indexes j, like j must be less than equal to n minus m. That's when m characters exist. Like now a dot substr j to m denotes like give me the first m characters in the string a which starts at index a. And now I can run a for loop and count at how many places the characters in this string and the original string are different. And I can take answer with minimum across all the possible values I had, and I can print the answer here. And this was essentially the solution here. Can we reduce time complexity? Yes, it is possible. Like I won't probably elaborate it for now. But yeah, it is possible to do this in 26 into n into log n time. The solution involves using FFT. Like you can probably join in the Discord server and I can share one code forces problem where you can try solving it out. So yeah, in fact, this is possible to do it in this time complexity. But in the interest of time, I will probably skip it. Okay, moving to the third problem, redundant array. It says Saf has an array A containing n positive integers. He can perform the following operation on array as many times as he can. Choose integers L to R. and choose a positive integer x and change every integer in this range to this value. The cost of such an operation is r minus l plus 1 dot x. If you notice, like this is essentially the length of element. So like you can see, like if you are changing 5 element, your cost is 5 times x. If you are changing 10 elements, your cost, like to summarize again, what we have been given is we have some array a1, a2, a3, a4, a5, a6 and so on. We, as many times as we want, we can choose some different ranges. We can choose some different ranges, for example this, and if we can change the all the values in this range. If we want to change every value of this to 5, then the cost we would have to pay would be 10 here. And for example, now if we want to change these elements to 8, our cost would be 3 into 8 here. So you notice, like one thing you can do is, like instead of selecting the range, just select one element at a time. Like for example, change this, like basically keep L equal to R always. Because changing two elements can be seen as selecting two elements and changing them. Like whether you select two elements in first or you individually select two elements, it's fine. And like essentially this is the idea. Like select L equal to R always. And then the idea is, like for example, if we change, and it's never optimal to change, like for example, let's take one of the example here. Let's just pick this 1, 4, 4, 5, 6. Now if we want to change everything to 6, then we will have to change this element, we will have to also change this element, we will have to also change this element. So the minimum cost we need would be 3 into 4. It's not optimal to change 4, remove 4 and erase 4 again. We should never do this. So what we can do is, like first is, like we can change everything to 1. Cost would be n, and for each element, if it appears k times, then the cost to replace all the other elements which is not equal to that element would be k into c. And we should take minimum over this, and that should be the idea. So minimum cost when we replace everything with 1, and I have created a frequency array, added all the sums into it, and for all the elements which appear in it, take answer with minimum whatever the value is, and n minus c, like whatever we require. And essentially that's the idea for this problem. Any questions on the first three problem before we move on to the div1 problems? And yeah, I am new to this problem solving. Can you help? How can I start? Like you can probably join the Discord server and check the roadmap to red channel over there. Why minimum is n? Like minimum is n because like we can replace everything with 1. Like it never says that x should be in the array. It never says x. So like if we replace everything with 1, then we are good. Right? So we can choose L equal to 1, R equal to n, x equal to 1. Cost here would be n, and everything is equal. And that is the reason why minimum is n. Okay, I will probably move on to the next problem then. It says amphibian escape. Chef is building a robot frog which he would like to be able to climb out of a wall quickly. Link is in the description there. The wall has height of h units. Initially, the frog is placed at the bottom of the well. Let A denotes the jumping power of frog and B denotes the slipperiness of well's wall. Initially, the frog is at position 0. Every second, the following two steps happen in order. Find first the frog will jump A unit upward along the wall. That is, x will increase by A. If it reaches a height of h units or greater, with this jump, it's considered to have climbed the wall and the process stops. Next, if it's within the wall, well, it will then slip B units downward. That is, x will reduce by B. Note that x cannot fall below 0. More formally, x gets changes to 0, x minus B. Chef hasn't decided on jumping power of the frog and also doesn't know the slipperiness of the wall. Given integers n, k and h, count the number of pairs A and B such that A is between 1 to n, 1 is between B is between 1 to n, and if frog has jumping power and slipperiness is B, the frog can escape the wall which has height h within k seconds. So like there are multiple ideas. First thing first. Let's say if A is greater than equal to x, then on first day frog is out of wall. Out of well. So like B can be anything. One important constraint here was like sum of n is less than 2e5 for all the test cases. So like what we can do is like we can iterate on all possible values of A. Like A equal to 1 to n. And now if we fix the value of A, then like what is the maximum distance frog can travel? It would be like up till k minus 1 day. Assume that the frog does not comes out of the well anytime. Then the maximum distance frog can travel is for k minus 1 day. He will move up k minus 1 times and he will fall back k minus 1 time. And on the kth day, like frog will move up A times and then move down B times. And if you notice, like this would is the maximum. This is the maximum possible height frog can reach. In k days. So if A into k minus 1 plus B into k minus 1 plus A is greater than equal to h, then the answer is yes. And otherwise the answer is no. Any questions so far? Yeah, like what I will come back to it again. But yeah, let's first assume that like we iterate on A equal to 1 to n. And for fixed A, we try to find what is the maximum value of B we can get. So for some fixed A and B, let's first say for fixed A and B, what is the maximum height frog can go up to? And like this is the maximum height frog can go up to. Any questions on this one first? Yeah, it's minus, sorry. Okay, again, so my height is like, let's say we have some given A and B, and like we want to find what is the maximum height frog can go up to. And also let's assume that frog never comes out of the well in the K days. Then what can happen is every day frog will go up A times, go down B times, go up A times, go down B times. So after first K minus 1 days, frog would go total K minus 1 times up and total B into K minus times down. And on the last day when frog is at height plus A, that is the maximum height frog would be at. And after that it will fall back to B. Like let's pick some example values. So on day 0, frog is here. On the first day, frog will jump to height 5. And then frog will come down 3 times. And he would be at height 2. Then frog will jump again 5 times. And frog will be at height 7. Then frog will jump down 3 height. And frog will be at height 4. And then frog will go up again 5. He would be at height 9. And then he will move back up to height to get height 6. So like this is the maximum height frog would be at. Assuming that A is greater than equal to B. Otherwise this may fail. So like after n minus 1, K minus 1 days, like every day frog jumps A minus B height, right? It goes up A times and comes back by B times. And on last day, this is the maximum height frog would be up. Assuming A is greater than equal to B. Does this make sense? Are you finding out that Kate second how much height it would cover? Yes, I am basically finding like what is the maximum height frog can go second or day. Like I am not sure what is the terminology here. So like once we know this, then what we can do is like we can run a for loop A equal to 1 to n. If A is greater than equal to h, answer plus equal to n, because that we don't care about value of b on the very first day frog would be out. Otherwise, we can binary search max value of b and do answer plus equal to b. And like this is the solution we have. For binary search, what we can do is like we can maintain some lower bound, some upper bound. Like upper bound would be like we can take infinity or whatever we want. And that format we will check A to K into K minus 1 minus B into K minus 1. B or like whatever, let's call it mid. To K minus 1 plus A is greater than equal to H. Then we say like high is like whatever, here we say like low equal to mid, otherwise high equal to mid. One thing we can check is like even if for b equal to 0, like frog should live or not. And like we can also find b in order 1 as well. Like binary search was something which looks easy, that's why I came up with this. You notice that what we need is ak minus b into k minus 1 is greater than equal to x, right? So we can also write this as ak minus h is greater than equal to b of k minus. So this equals to like ak minus h by k minus 1 is greater than equal to b. So like we can take floor here. And like this is the maximum possible value of b we have. And like that would be the other solution we have. And like now the question is, what does sum of value of n signify? I will say if a is greater than equal to n, continue. If a star k is less than n, then like the frog can never reach the given height. And now like otherwise we can say like max b we can have is k into a minus h by k minus 1, and we can do answer plus equal to max b. Like you should also take minimum with n here and print what are the answer given. Like it's time complexity and like, yeah, 1 second. Now let's say sum of n is not given to us. It's just given to us that n is up to 2e5 and t is up to 1e4. Then what would be our time complexity? If n equal to 1e5 and t equal to 1e4, like for all the test cases. Because for every test case we run a for loop of length n. So overall time complexity here would be n into t, which would be around 1e9, 10 to the power 9, and it should get TLE. But what we can notice is that when we have been given that sum of n for each test case is less than 2e5, 2 into 10 to the power 5. What we know is like this is an impossible test case. And if you look closely, like our overall time complexity is like sum of n1 plus n2 plus n3 and so on up to nt, like sum of value of each n. And we know that this sum would be less than 2 into 10 to the power 5. And that's why like our original approach which runs a for loop will get an AC instead of a TLE. And like this is critical. Like for example, if first test case has n equal to 5000, second test case has n equal to 5000, third test case has n equal to 90,000, then for remaining test case like sum of n would be less than equal to 10,000, something like that. And like that is the main reason like you will notice a lot of problem gives constraint on sum of n. Like it might be possible to solve it without sum and constraint, but like the code would be really ugly. So any questions on this problem before we move on to the next problem? For binary search one, you can say like the binary factor for log would be log 10 to the power 9, which would be around 30 or something. And sum is still n. So n log n due to binary search, yeah. If you are not doing it with order one. Second problem says perfect prefixes. A permutation of length n is an array of length n that contains every integer from 1 to n exactly once. For example, 132 and 213 are permutations, while 212 and 342 are not. Beauty of a permutation is defined as number of prefixes of p that are themselves permutation. That is, it is the number of integer I such that the array p1 to pi is a permutation of length I. It basically means that for every number from 1 to I, all the numbers would be present in this array. You are given permutation p of length n, you can perform following operation on it at most one. Choose two integers L and R such that this is given to you and L and R have different parities. That is else, like basically we have to choose an even length array and then we can swap first two numbers from the each element. In simpler word, you can choose a sub array of P that has even length and partition into blocks of length and swap the elements in that block. For example, 3, 1, 5, 2, 6, 4, etc. And if we choose between 2 to 5, then we will swap 1, 5 and 2, 6. And it says like after you do this operation once, what is the maximum possible beauty of P that we can operate? Any questions on the problem statement first before we try to solve it? So like once assuming that there are no questions like difficulty, like I find it difficult to rate the problem, but not max. I would say you can call it max max. The idea is first question is how to check if P1 up to Pi is permutation of 1 to n. First question first, like only if we can try to find it for each I. Okay, what unable to understand what is the problem. So let's pick this sample 3 1 or like let me just write a random permutation. Let's write a permutation. Let's say 3 1 2 4 5 6 7 8 9. Let's say this is the permutation to us. What it says is like first you have to count like how many indexes, like the starting values are a permutation here. Like first question first, I am assuming everyone knows what is permutation. The operation you are allowed to do is you can choose a continuous blocks of two elements and then you can swap these elements. It should be a continuous block. So like if this is the range you choose, then this is your final permutation. This is one part of it. The next, like this is the operation we have. And what we have to maximize is like number of permutations, like let's say this is the final permutation we want. Then here like will check for each I equal to 1 to n if P1, P2 up to Pi contains all the elements from 1 to I. And we want the number of such I to be maximum possible. So for example, in this permutation, this is one good I where like first one element is equal to 1. The next good eye is this, where among the first three elements, all the three elements are present. This is next good eye. 6 is also good. 7 is also good here. And 8 is also good here. So answer in this case would be 1, 2, 3, 4, 5, 6. 6 such elements are there. So like there are two parts of this problem. One is understanding the operation we are doing, and another is understanding after the operation at how many indexes we have first I elements. Any questions on the problem statement? Like there are multiple ways to approach this problem. What I did was I used DP here. Like there should be some greedy ideas. Can actual sum and sum can find? I don't think sum will not work. Like first question first, how we check if P1, P2 up to Pi is permutation? Like basically all the elements from 1 to I appear in the first I element. Like there are two ideas. One is Jorbit Hessing and another is check max value of P1, P2 up to Pi, and it should be equal to I. These are the two ways you can check. Yeah, max till I should be equal to I. That is one idea. Some will not work. In fact, actually some will also work. And the third idea is you can also look at sum. Sum should be equal to I into I plus 1 by 2. Sum also works. Yeah, so like these three ideas are there. And what I did was I used DP. Like I had three different kinds of, like each DP has three value. Like if you look at it, like your original array looks like this. There would be up to some indexes where you did nothing. Then at some places you will do some swaps, and then you will do nothing. So call it phase 1. Let's call this phase 2. And let's call it doing nothing at last is phase 3. And we can say like phase 1 I denotes maximum number of index, like maximum number of indexes if we do nothing up to 1 to I. Phase 2 I says maximum number of index where we would be at, where like we would do some swaps up to I in some suffix over here. Some swaps here would be required and you can do nothing here. And phase 3 I means like you started it at some place, then you did some swaps, and then you are back to normal path again where you would be doing nothing. These are the three different DPs I have. And like this is what we need here. And like now, like we can do transitions here. Like transitions would be like if P1 up to Pi is permutation, then phase 1 I would be equal to 1 plus phase 1 I minus 1. That is the only case we can have. For phase 2 we can check if P1 P2 I minus 2 comma Pi is permutation of 1 to I minus 1 and like count plus plus. Like we start count equal to phase 2 I minus 2, like what is the maximum you got after up to I minus 2, where like here you have done some swaps and you did nothing here. Now when we are doing a swap here, this is initial count. We can check like after swap, after Pi minus 2 Pi minus 1 comes in. So if it's permutation of I minus 1, do count plus plus, and then also check Pi up to Pi minus 2 Pi minus 1 comma Pi is permutation of 1 up to I, and also do count plus plus, and you can mark it as phase 2I. And for phase 3, like you can do this similar. Phase 3I equal to max of all the phases we have, phase 1 I minus 1, phase 2 I minus 1, phase 3 I minus 1, and do plus 1 if P1 up to Pi if P1 up to Pi is permutation of 1 to 1. And like this is the main idea I had for this problem. Yeah, like the problem with Kden is like you generally used to get max sub array sum, but it's not related here. Although you need the index where max is equal to something, but you don't need max sub array. This is one hashing, like it often comes helpful, like you might want to take a look at it. So like I tried to do some. So what we need is prefix sum. Up to elements I would be prefix sum plus x. And like we can also say like correct sum. Correct sum I denotes like the ideal sum we want. So like now I can either use like a tuple kind of a thing, or I can call it phase 1, phase 2, phase 3. dp1, dp2, dp3 and plus 1. dp1 up to j is what is the maximum value you can get up to j, and like the sum of up to j should be equal to correct sum. For dp3 you can take max of all the elements and dp3 j minus 1, and like prefix sum up to j should be equal to correct sum. And now if j is greater than equal to 2, what we do is like we start maximum of dp2 j minus 2 comma dp1 j minus 2. Now we will do swap aj minus 1 and aj. So like sum equal to perhaps sum of first two elements, first j minus 1 element, sum plus equal to aj. If this sum is equal to correct sum j minus 1, we do count plus plus. And like now we do aj minus 1, this is the swap, right? And now if dp2j equal to this count, and at last like we can print at whatever phase we are at. And this was the idea I had. So like I'm not sure if there are some greedy ideas for this one, but like I found like DP relatively easy here. So any questions on this one? Looks like my Zoom has died, so I will switch the meeting. Any questions? Okay, like greedy does exist, like I'm not denying it, just that I found it relatively easy to code DP here. Okay, like idea again, sure. So the main idea is if we look at the original permutations where we have done some swaps. One second. My idea was like if you look at the original permutations and like if this is the range where you are making some swaps, then you can essentially say that the array can be divided into three different phases. Up till some element, you did nothing. I call it phase 1. Then there would be a phase where you would be shifting to two elements, which I call phase 2. And there would be a last phase where you would be again doing nothing. And my idea is like I call it phase 1I. What is the maximum correct index you can get up to element I when index I is in phase 1 only? I call it phase 2I, the maximum DP value we can get if index I is the last element of some swap here. And phase 3I when we are done with this swapping and we have some index I here. Like I can try to search for it, like definitely there are questions on this type of problem. Now the idea is like when you are in phase 1, you don't really have a choice here. For index I, you check if 1 to I forms a permutation, and whatever be the maximum value you get here, you add +1 to the answer. For phase 2, like you have two different cases. Either it is the first time when you are making a swap, or you are making a swap when already some moves in the past have been made. And for phase 3, like you again have two different choices. Either like you are at the back of something, or like you simply skip this phase altogether and you did nothing here. And like now there are DP transitions on this one. And because it says at most one operation, so it's fine to skip some of the phases here. And essentially, like this is the solution I had. Any questions on this one again? The idea is you can also extend it to phase 4 and 5, something like that. So that like you can make at most 2 such operation, at most 3 such operation, at most 4 such operations you want. This might complicate it a bit, but might be possible to do it. So I will move to the next problem, possible contenders. Like this one did took quite a lot of time for me. But I think we would be able to get it. It says you have an array A of length n. You can perform the following operation on it as many times as you like. Choose two integers L to R and delete the elements AL to AR from I and change it with the median in that place. Now some types of operations are given. Like for example, if you have 4 2 7 5 9 4, then if you choose 2 to 4 this element, then the median here is 5. So your new array becomes 4 5 9 7. And it says for each I, we have to decide whether there exists some sequence of operations such that the value is equal to AI at the last. And for median definition, it says if it's odd, it's the middlemost element. Here in this case, it's 3. If it's even, then we should take the smaller of the two middles here. Any questions on the problem statement first before we move on to some solution or something, how to solve this problem? So like assuming there are no questions on the problem statement. So I will move to the solution then. So like my main idea is let's pick some example array. Okay, didn't understood the problem statement. So let's pick some sample here. Let's just pick this one. And it says like we can choose some index L to R here. For example, if we choose this, then we should first find median of we should find median of 275. What is median? I will take a look at it later, but let's for now believe me that the median is 5 here. Then you delete this and replace it with 5. 4 5 9 4. Now let's say you have chosen this element. Believe me, like for now that the median is 5 here. So we replace it with 4 5 4. Now let's say we have chosen this as the array here. The median here is 4, so it's 4. So it asks us to find like all the possible elements if we keep doing operation like this. What is the last single element we can have? And median is defined as median of some array. A is defined as sort A. If length is odd, take middlemost element. If length is even, there would be two elements in the middle like 3, 4, 6, 5, 4, 2, 4, 1. If we sort it, it becomes 2, 3, 4, 4, 6, 5. Like let's call it 3 then. If this is the sorted array, then in case of even length, there are two medians. It's just as pick the smaller one. And like this is what we have to do. Any questions on the problem statement again? Okay, nice. So the idea is greedy. Let's do some brute force first. Can people in the chat give me some array of length 10? Brute force plus greedy idea. Like 2233 is relatively a simple case, but like for example, you can take 2233. First take this, your final element here would be 2, 3. And now if you take median, you will get 2 remaining. That's how you can get 2. And and if you take these two elements, the median here is 2. No. If you take these elements, median here is 3. And like the answer is 2 is possible, but 3 is not. Or wait, 3 is possible. Two, two, three, three. If we take 2, 3, the median is 2. 2, 2, 3, the median is 2. 2, 2, like complete array, the median is 2. Like why the answer? Oh yeah, 2 to first, got it. So the idea is first take these two elements. It becomes 2, 3, 3. Now take this. It will become 3. And like this is the idea. So yeah, someone has said some error in the chat. It says like 4, 2, 1, 6, 5, 3, 6, 4, 3. Let's say this is my error. 3, 4, say all single digit numbers are there. And I want to check if answer equal to 4 is possible. So what I will do is like I will look at each element. Some of the element would be greater than 4. Some of the elements would be less than 4. Some of the elements would be equal to 4. This is less than 4. Green are equal to 4. This is again less than 4, less than 4. This is greater than 4, greater than 4. And let's change this number here. 2, 1 is there. So these blue elements are less than 4. So like if I write it down again, 3, 2, 1, 6, 5, 3, 2, 1 again, and then we have 4, 4 here. First thing we should do is like we should look at all the elements which are less than 4 and try to change them into 1. So first type of operation would be apply here, here and here, and change it to a single number. And what it matters is like all of these number will always be less than 4, and it will all change collapse into single digit. So if I write it correctly, write it again, the number becomes 3, 4, 4, 1, 6, 5, 2. And like the only thing we need here is, and if you look at this complete array, right, there are 4 numbers greater than equal to 4, which is 4, 4, 6, 5, and 3 numbers less than 4. So the answer in this case is yes. How? Like you first take these 3 elements. Here 2 would be gone, 6 would be gone. And you would be left with 3, 4, 4. Next time you can take this. Now this 1 would be gone, 5 would be gone. You would be left with 3, 4, 4, and if you take this, your final answer is 4 here. So the answer is yes here. And like this is the first thing we should do. Like to summarize again, let's say we want to check if we can make answer equal to 4 at last. So first thing first, look at all the numbers and look at all the consecutive numbers which are less than 4 and make operations there to change all those numbers into a single only one number. So in this case we apply operation on 2, 1 to get only one number here between 4 and 6. And we apply one operation on 3 to 1 to get one number which would be less than 4 and which would be at last. So like this is how our final, after doing these operations, we would get 3, 4, 4, 1, 6, 5, 2. Now the only thing we need is the count of numbers which are greater than equal to 4 and count of numbers which are less than equal to 4. Which are less than 4. Count of numbers which are greater than equal to 4. And what I claim is if count 2 is greater than count 1, the answer is yes. And essentially this is what we need here. Like once we know this, like we can probably maintain consecutive equal segments and try to solve this further. Like this is the main idea. Any questions on this brute force idea before we optimize it to some better time complexity? So like this is the main crux of the problem. Like why is it correct is like, if you look at the median, right, you will see like for each one smaller element, you have to remove one larger element there. Element less than 4, we have to remove one element greater than equal to 4. Because like if the median is the middle element, right? So for this, there should be a pairing number at the back. And the idea is try to make this as less number as possible. And on this side, like we can always merge consecutive segment to reduce the numbers here. So if there are 5 elements less than 4 after the first operation, what we need is these 5 elements, then 4, and then 5 elements greater than 4. And like the main idea is we will always be able to make it in such a way. Because if there are 10 elements greater than 4, you can do some operations there to remove 5 elements from there. And like this is the main crux of the idea. Like you can just pick that number with one neighboring number. One of the large number will be gone, whether it's less than 4, 4 or greater than 4. So that's how you can get it done. So like once we understood this brute force idea, what I will do is like maintain an element like where everything is 1 first. Process in increasing order. Of elements. So when we are at element, let's say x, for all the elements less than x, change them to 0. So like let's say when we are processing this element, this is 0. And now what we need is count of segments, consecutive segments with zeros. Like finally, these would be the after first round of operations. This would be the count of numbers which are less than the current number we are processing. And we can also know like how many numbers we have to get how many numbers which are greater than equal to current number. Yeah, like the main idea is try to play around with it, some different types of operation. Like 2 to 3 is a big hint. Like why we need 2 to first. And how after 2 to 3 we can get it, like try to play around with 2 to 4 3 and see what can you do there. And like this is the main idea. And like I maintained a set where I can get all the medians. This is the set which consists of all the medians. And like here I have sorted all the indexes first. Now like my count this is count of segment small, count large or equal. So if count large or equal is greater than equal to count segment small, then it's possible to get current index as the median. So insert it in the possible medians here. Now for the remaining elements, like for the other elements, like count large or small will decrease. Current element would be marked as 0, and your segment increases by 1. Now if element just before it is also 0, then essentially we can merge these two segments here. Some element up to I minus 1. This is index I minus 1, and this is 0 what we have made. This is the ith 0 which we have made right now. So like count segment small decreases. Similarly, if the next element is also 0, then we can merge segments again. Then there are some segments of zeros and so on. We can merge these as well. And like this is the main idea. At last, we want final string. So if we look at the x is in median set, then add 1, otherwise 0 and return s. And print the set we have. And this was the main solution idea I had. Like there is one more problem on this one. There is a recent code forces problem as well, which asks us to find what is the maximum median we can get if we do these operations. I can share the problem link as well. Like this is a good problem it solves. Instead of finding all the medians, find the maximum value of median you can get if you do these operations. Play around with this one, then probably this is the code forces problem would be an easier version of CodeChef problem. Then you can jump back to the CodeChef problem. Any questions on this one before we move on to the last problem for today? Okay, I will move on to the next problem. Like basically initialized to 1 was basically me saying 1 for element which is greater than equal to median and 0 for element less than the current element we want. And what we are trying to do is like, can we get final element equal to x for some of the elements there? And then like playing around, like essentially like what I was playing with the segments there, I just changed them to a different terminology to say them 0 or 1. Like instead of 0, 1, you can consider it as a Boolean vector is less than median. 0 means false means element is less than median, true means element greater than median. So what we can do is for all the indexes where the element is false, apply operation there to get only one element like that. Okay, it says a flower shop has and flowers for sale. These flowers are arranged in a row from left to right. The ith flower has color Ci. You would like to buy some continuous range of these flowers. Specifically, you have shortlisted M ranges of flowers. The ith range starts from Li to Ri and includes both the endpoint. For two ranges I to J, f of ij is defined as number of colors which are present in the ith range but not in the jth range. And at last it says di is the sum of number of all the colors with all the indexes which are present. Like first, sum of all the values of f with the other index. and it says print the value from D1 to DM. Any questions on the problem statement, or should I try to simplify it before I go into the solution for this one? So let's take some example here. Let's see if this is the length. Let's say this is the length here. And let's say the first range is this. And second range is this. And let's call it I equal to 1, j equal to 1, j equal to 2. Then f of ij is number of colors which are present here but not here. So like 3 is not present here but not here. So here 3, 7 is present here but 7 is not present here. So 7 is also allowed. Like we don't have to not, we have to count 7 only once, not twice. 2 is present here but is also present here, so it should not be counted. So number of such colors are 2. So f of I comma j is 2. And it says bi is defined as sum of all fi comma all possible j's here. And we have to find it for every element. So first thing first, what we can do is like for each color, count number of ranges in which it is not present. So for example, if we take 2, there would be some elements, then 2, some elements 2, some elements 2, some elements 2, and some elements at the last. So first let's count the number of range which start and end on these segments. And then what we can do is like for each range. So for example, our range was 7. So for each distinct element in this, like with let's say this is count 2. Number of ranges which do not have 2. Then here if our range is 7, 7, 2, 3, what we need is count 7 plus count 2 plus count 3. Like instead of counting the number of colors which are present in I but not in J, what we count is for each color which is present in I, count the number of ranges where this color is not present. And this is what we need. So for 2, like what we can do is like first we can try to pre-compute. I did the coordinate compression, but that is not required. For each element where it's present, create a vector of vector there and push all the indexes there. And then for each color, if it's not present anywhere, ignore it. Otherwise, you can find all the ranges which start and end here. So it's essentially saying doing offline. I think offline was not required, but I anyways did it over here. Like count the number of ranges with start and end between L to R and add it for color C. Like I explicitly don't need the other color, but I anyways ended up doing it offline. Offline, but not required. So at last, like this was some offline. And now this res vector, where is the res? Like now this res vector contains for each color how many sequences are there where this color is not present. If it's empty, then we can say that res C equal to M. Like it's not present in any sequence. Now the second part is like once we know this, for each range, like it's sweep line technique again. Like for each range, I am trying to find like for all the elements where this range ends, like how many distinct colors are there and what are the sum of those values here. And like this is essentially added into my answer value and I am printing answer at last. Probably a brief summary, but yeah, like there are few things that you need to learn before you can probably solve this one. What we need is sweep line technique, how to count distinct elements in a range, or like sum of distinct elements in a range, and like these are the two things you need, and then you have to club. Yeah, like for probably offline and sweep line, I will probably end up linking some resources here. Like you can go to USAO guide, like it's really a good guide to read out about different techniques. So you can probably read this article here and there are some sample problems for you to solve as well. I don't see a dedicated article here, but not this one. Like for example, this is one like you are given an array, you have to count number of sub-arrays where there are at most 8 distinct values. How do you do it? You can probably try to solve this problem. Yeah, like this is the one you should solve. This problem says count distinct values. But once you know for each element how many times, how many sequences that element is not present, this problem changes to count sum of values, distinct values in the range from A to B. So you can try to solve these two problems first, and then you can jump back to this problem. It will become a bit easier compared to just trying to do it this problem as well. So yeah, like these can be some homework exercises here. And I think with this, I will probably end my stream. If there are some questions from the chat, I would be happy to answer them. And like I am almost close like for my Zoom meeting and also. So any questions from the chat before we end today's stream? Can you briefly explain problem day of lead code bi-weekly? Yeah, like probably I don't have a whiteboard now, but so like the main idea I had was, I am assuming like people who know the problem would be solved. Like I won't go into the detail. The main idea was, let's try to construct the elements here. So like we will have some one first. Let's say like we don't have any element at first. So you will insert one somewhere. Now where do you insert two? You have two possible choices. Either you insert before two, one, or you insert after one. And let's also maintain the count of elements here. If you insert it before two, then number of inversions increases by one. And in this case, there are no inversions. Now where do you insert 3? Here, here, here. If you insert 3 at last, there are no new inversions. If you insert 3 just before it, there would be one extra inversion. If you insert 3 here, there would be 2 more inversions here. Let's say we inserted 3 here. Where do we insert 4? Here, here, here. 3 possible choices. Let's say if we insert it here, then the number of new inversions have increased by 2. So you notice whenever you insert one, let's say when you are inserting 10, the number of inversions you can increase would be from 0 to 9. If you insert just at the end, no new inversions. If you insert in the starting, there would be 9 inversions. If you insert it at fourth last from the end, there would be 3 more inversions and so on. So the main idea is, we can have 0 to I possible different inversions here. And now the next part was to do dp there. dp I j. We have inserted first I elements. And total number of is j. And like that's what I remember from the problem statement. And like to do it further, like I will have to probably read the problem again. Yeah, so it just says up to index I there are count I inversions. So like the other idea was probably we can try to renumber the elements here. Like my main idea was like we can try to reorder elements in such a way that we can do whatever we want. Like the other idea was like instead of inserting 1, 2, 3 over there, you can probably, the other way to look at it is like, let's say we have 1 here. Now if we want to increase number of inversion by 1, then we renumber elements like this. Now let's say we want to increase, now for, and we are inserting the third element, we want 2 inversions. If we want 2 inversions, then the last element should be 3, and we can change the earlier 1 to 2 here and 2 to 3 here. Like basically we are adding new element at the last and we are shifting some of the elements. Now let's say we want to make 5 inversions. Now let's say we want to make 2 inversions again. So 2 inversions, the last element should be 2 and renumber all the elements before it. 1 does not changes. Change 2 to 3 and change 3 to 4 here. So this would be the element 4, 3, 1, 2, where when you inserted the last element, the count of inversions has increased by 2. Now let's say we want to increase the count of inversions by 3. So the idea would be insert this is the original element. If you want to increase the count of inversions by 3, then add 2 here, change this 2 to 3, change this 3 to 4, change this 3 to 5, and so on. And when you are doing this, for some requirement type, if you want exactly count type permutations, you can change all the other dp values to 0. And this is the crux of the problem I had. Like the previous inversion so far and new inversions we want dp on that. And if we want some exact requirements, then I change all the other dp values to 0. And this was the idea. And I think this was the briefing, and probably thanks everyone for joining today. And I think I will probably end the stream. So thanks everyone for joining today. Okay, hello Akash. Like, do you have some question or like? So you can probably ask it. I'm not sure if it's solving some of the questions. I will probably skip it. Okay, what should I do to upsolve? Like, when you are upsolving, you are solving problems from one of the contests, right? So there are editorial always, sometimes video, but text editorials are always there. So for example, this is the contest where text editorial is present. You can read it. You can use the comment section to ask for some help questions. You can try to look at some prerequisite if you don't understand something. You can probably join some Discord server and try to discuss problems there and basically try to solve it. And if you are looking for like probably the only solution is to just grind. Nothing more, to be honest, we can probably do. And like that's what I have mentioned in my roadmap to RAD in 2 minutes. Like you can sometimes you will read about some topics, something you will try to learn some new techniques. Sometimes you just keep solving and just keep going. Like there are no shortcuts, to be honest, or some magical tricks. Like this is pretty much the only way And like one thing I would say is like the number of problems which one needs to reach to some level can be different for different people based on whether they have some past background or not, etc. So I will probably end this sprint. Thanks everyone for